Hello friends, good evening. Okay, so yesterday I explained something about transistors. I think you have understood quite a bit, but still I will make it very clear to all of you. Okay, right? So quick recap. Yesterday we had drawn the transistor like this, right? So we had taken N, P, N, and we had forward biased this junction by connecting a resistor here, and yes, if necessary, one more resistor here, and then we had reverse biased this junction by connecting this and this, like this. We have taken this as the common point. So this junction is called base emitter region. I suppose all of you know emitter, base, collector. So this junction is called base emitter region. This junction is called collector base junction. Okay, so base emitter is forward biased. This is forward biased, and this is reverse biased. And then I had told you yesterday, quick recap. This is lightly doped, and this is heavily doped, and this is moderately doped. Okay, I hope you remember that. As a consequence of this, due to forward bias, you will have lots of majority carriers flowing from this to this, that being the electrons. And the holes will also go from here to here, but these holes are negligible in quantity. I hope you remember this. Okay, alright. Now I also told that due to this reverse bias, because see, this junction is reverse bias, now the electrons here are minority carriers in this place, and the reverse bias will act to pull the electrons. Okay, so the minority charges here will be further pulled in. So in other words, some of them will recombine. Some of the electrons will recombine with the holes, and that we show it as the base current. Okay, so here 95% of the approximately 95% of the electrons which come here will come to the collector region, and then it will go here as the collector. So this current is called the emitter current, collector current, and this current is called the base current. I think to this extent we have explained everything yesterday. Okay, well, I'll just elaborate some more things here. And this we call it as RB, RE, and this will give the name as RB. Okay, now this one I will model it. I will model this. How will I model this? Okay, now see the modeling of this. I will draw this one RE like this, and then I am going to draw this junction as a diode. This junction as a diode. I suppose you are understanding. This NP, I am drawing it as a diode. Of course, I should draw it ulta, right? So this one is drawn like this. This one. So this is RE, and this is VB, and then of course I'm also going to show you this resistor, which is written as RE. Now I suppose you can understand here that the current flowing here, so whatever current is flowing here, the same current is flowing here, and I will call this current, so this same current, this current is IE only, so I will take this current as IE. Okay, this current is IE. Here in this case, since I am only showing this, IB will be equal to IE if you do like this. Okay? Hello, are you with me, all of you? Yes. Okay, then you see, this current is going like this. I mean, the electrons are going like this, the current will be ulta. Okay, the current will be, I am only showing the electron current here. Showing the electron current. Electron current, ulta of that is the conventional current. Now, this electron current is the reverse saturation current because it is going through the reverse bias. Do you agree, students?
Yes.
Your friends are not telling yes there. Hey, nee jor helo yes anta volume increase madale. So this current is reverse bias. So everybody say yes, sir. So you know the reverse bias characteristic will be like this.
Yes, sir.
That means over a large variation of this voltage, the current is constant. So therefore, this electron current, I will show it as a current source, not as a voltage source. Agreed? Ulta. As a voltage source. Agreed? What shall I do when I take it ulta bias? Correct, no, correct. This is only right. Because electron, it is ulta of the electron, no? Adil, ulta of electron. Here Arun is sitting here, huh? So Arun is master of this. So Arun is telling right ulta, sir, I will write ulta. Now, I told 95% of this IE will be here. That means IC will be a fraction of IE. So I write it as alpha times IE. And alpha is less than 1. Agree? Sorry.
Yes, sir.
Alpha times IE. And alpha is less than 1. Understood?
Yes, sir.
So this current, I can write it as alpha times IE. Agreed?
Yes, sir.
And you know the concept of constant current source. That means the current will be constant irrespective of the load, right? And then, of course, this end, I am going to write this. Okay. Now, this one is called RC, and this can also be RL. The load resistance. This can also be the load resistance, or this can also be RC. So if I take the output at this point, what will be this output? This output, anybody? What is the output? VO is equal to?
Alpha into I.
I into RC.
IC into
Us.
I RC.
Okay, happen. So that. Or this is alpha IE into RC. Agree?
Yes, sir.
Put it like this. This is one way to put it. One way to put it. Okay. Now, one more important thing I want to tell you, all of you. Now, you see here. This RB will be very, very small compared to RE. RB will be very, very small compared to RE. So, under that circumstance, this current I can take it as constant current. See, what is the concept of constant current? If you have a voltage source and if you are having a resistance here R1 and here you have got a resistance R and this R is varying say plus or minus delta R. This is V, and supposing this plus or minus delta R, that is R plus or minus delta R is very, very small than R1. That is, this, if R varies, this current will vary.
Yes.
Hello? In friends, no, hello, yes, and
Yes, sir.
no, either problem. So, if R varies, this current will vary. But if you say the percentage of this current vary as this is varying is say less than 1% or something. So, for all practical purpose, you can take this current to be constant. Got it?
Yes, sir.
So for all practical purpose, I can write this as what? As a current source with this resistor. I suppose you remember we have done this.
Yes, sir.
Thevenin equivalent. What is this current source here? V by R.
Yes.
The value of this. And what is this? This is R1. So I can now write this as R plus delta R. That is, this is acting like a constant current source with this resistor. So this current, what you see get here will be constant. Got it?
Yes, sir.
Hello?
Yes, sir.
So now I can consider this current under the same circumstance. That is, this RB is very, very small compared to this RE, and therefore I can consider IE to be constant. Agreed?
Yes, sir.
You have to keep your mic on and tell me yes sir, no sir. I want to be convinced that you are understanding. I am not teaching some ball. Now, I wrote one more equation. IE is equal to IB plus IC. I hope you remember this.
Yes,
The
sir.
current through RB should be constant.
Current through?
RB should be constant.
No. This IE I will take it constant. No, hold on. This IE I am taking it constant because it's like this. RB I am adding here RB something like this. So see, if I only isolate this, then RB and this current are same. If I isolate, but now I am not isolating it because once you put the collector circuit, then you cannot say IB is equal to IE. Okay? No, just now. Now you see here, if IE is constant, if IE is constant, okay, what does that mean? That means now, if IB now becomes IB plus delta IB, supposing, then what should happen? Supposing IE is constant, then what should happen to IC?
IC minus delta.
Yes, it should be IC minus delta IC. Got it now? So if this increases, this should decrease. This increases, this should decrease. Got it? So that means now,
That decrease will be equal to that increase.
wait a minute. See, now don't concentrate on that. Decrease must be equal to increase. Don't worry on that. I just hold on. I tell you what. Hold on. Right now, what I want you to appreciate is if IB changes, IC will change. I want you to appreciate that. Can you appreciate that?
Yes, yes.
I just want that relation. IB changes, IC changes. Okay? IB changes, IC changes. That's what you have to appreciate. Provided IE is constant. Provided IE is constant. Got it?
Yes, sir.
Under that circumstance, I can now write, under this circumstance, which circumstance IE is constant, I can now write IC is proportional to IB. See, I have given the number here, that is, this whatever current comes here, percentage of that will come here.
Yes.
That means this current is proportional to this current, and now this current minus this current is this current. So I can write this current is proportional to this current also I can write. So here I am going to use a different proportionality constant. What is it? IC is equal to beta times IB. I am going to write like this. Here I have written IC is equal to alpha times IE. Some constant. Now I will relate. I will relate alpha and beta. I will relate. I will tell you. These are all important constants. So did you appreciate this?
Yes, sir. Yes, sir.
Now here you see, beta is very much larger than 1. What does it mean? Small change in beta, small change in IB will reflect as large change in IC. Agreed?
Yes.
See, now you recollect what I told yesterday. Here the current will change by small quantity, right? So you see this equation, no? You see this equation.
Yes,
So here IB changes by small quantity. I am relating this to this. See, now your thing is if you make IE constant here, then delta IB must be equal to delta IC. That is your doubt. That is your basic question, isn't it? That's your basic question. So delta IB must be equal to delta IC. That is your question. Okay. Now how should I put this to you? Now here your doubt is, if delta IB increases, delta IC will decrease by same quantity, then IE is constant. Now when I wrote this with an intention just to tell you that IB and IC are related to one another. That was the intention. Okay. Now I tell you that was just written because I wanted to show this relation. But actual relation what happens? Actual relation what happens? Now here if you see this input characteristics. If you see the input characteristics, here. So the input characteristics is what? Now this voltage, what is this? This is the voltage with respect to ground, and this is the voltage with respect to ground also. Correct? Hello?
Hmm.
Hello?
Yes.
Huh?
Yes, sir.
Now, here you see, if this current varies, this voltage will also vary. So, the forward voltage VD, so now this is a junction, the forward voltage VD will also vary. So, this is just behaving, see this junction is behaving just like a diode. So, diode forward characteristics, how is the diode forward characteristics? The diode forward characteristics is like this. Clear? So, here when I started this, my operating point was somewhere here. Now, whether this voltage will increase or decrease. If it decreases, see, this is VD. Here VD becomes what? VBE. And this becomes what? This becomes IB. IB versus VB. Initially, the operating point was here. Some for some VB, this IB was there. Now, if VBE decreases, okay, or VBE increases, corresponding change in IB. Agreed?
Yes.
So here you see, I said if you take IE is constant, then if you take this relation, this corresponding this changes, then correspondingly this is changing. But frankly speaking, what happens here is IE will not be constant. Why? Because the characteristic is like this.
Okay.
Correct? Under that circumstance, there is, for every change here, there is a percentage change here. It will not be exactly equal. Correct?
Yes, yes.
So under that circumstance, I can write like this. Agreed?
Okay.
So that is the basic relation. So I can now write this relation as beta times IB into RC. Output I can write alpha times IE into RC or beta times IB into RC. Clear?
Yes.
Fine. See now very quickly. I hope I was able to correlate this with this piecewise linearization, okay, and this model, and I am able to get this.
Yes, yes.
I hope this is all clear to all of you.
Yes.
Yes, sir.
Good,
Sir.
Very good, very good, very good, very good, very good. Okay. Now I am going to do the next operation. So if you have understood this, that operation will be clear. Okay. So I said this is initially when you have chosen some voltage here, some resistor here and all, you will get this as the operating point. Agreed? Operating point. See, now here, what does this graph mean? For certain value of VBB, certain value of RE, certain value of RB, then I will get a particular value of IB and the corresponding value of VB. Correct?
Yes, yes.
So then the coinciding, that is for this value of IB, for this value of VB, this is the point of intersection on the characteristic of the diode. That is the base emitter junction characteristics. So this is called operating point. Operating point. Henceforth, you should get familiar with this one. So what I am trying to tell you is, initially you fix the operating point. Around the operating point, the signal is varying. That is the idea behind that operating point. Okay?
So that operating point can vary in the correct.
Depends upon what value you have chosen this, what value you have chosen this, what value you have chosen this. It's simple, man. VBB divided by RE plus RB minus V cutting will be equal to what? Will be equal to this point. And that divided by the resistance will give you this.
Yes, sir.
That is the operating.
Yes, sir.
Correct? Right. So I hope this model you understood. How this model works. So I have converted this into current source, etc., etc. Now, what is the significance of this current source? What is the significance of this current source?
If we change RC also, it will not.
Brilliant, brilliant. That is it. So if you change RC, this IC will not change. IC will be constant. Change RC, IC will not change. That is what happens in a transistor. Okay, so the output will be current source. So, and this current is controlled by this base current or emitter current. That is what you have to see. And collector current is controlled by the base current. Got it? Collector current is controlled by the base current. Got it?
Yes, sir.
And it is easy to vary the base current. And you will get a corresponding change in the collector current. And your collector current, it is now, it is able to, you are able to control the current. Now, the next thing that I am going to tell you will be very, very much important. So, मैं क्या करता हूँ इन सब को हटाता हूँ. Okay, now you see here there is VO. VO will be, as I wrote here, VO will be beta times IB into RC. This is what I had written. Okay? Okay. Now you see what I am going to do. I am going to add here, I am going to add here or here a signal source. I am going to add here a signal source. Small signal source. Very small signal. That is, this is signal source means this voltage will vary with this. I am adding a voltage source. Okay. So if I add a voltage source here, what is the consequence? This current, what will happen to this current? Because of this source, there is IB flowing here. Now, because of this source, there will be one more current that will be flowing. This current is flowing because of this. This current is flowing because of this. Agreed?
Yes.
And I am showing I by small letter, meaning that it is varying with respect to time. So what happens to this current? What happens to this current? This current will now be IC plus small ic. IC plus small ic. Got it?
Yes.
Your friends will hear. You tell I didn't understand, sir. I will explain. That's a good question.
It's very good.
That's it. No, he's got a point there. Good man. Good. I didn't want to take that phase here, but you are a brilliant student. Are you happy now? Not so happy.
Sir, but like that variation is because of some new voltage source, no, sir? So, like IC should.
बोलो देखो मैं क्या बोल रहा हूँ अभी देखो ये वोल्टेज सोर्स मैंने इंट्रोड्यूस किया so if I introduce a voltage source you see this circuit no in this circuit this current has to change and this current is dependent on this current no so if this current varies this current also should vary correct no
here IE will also change no?
I will see if this changes automatically IE will also change. IE will also change by small amount. What I am trying to tell you is I am introducing a small signal voltage and there is a small variation in the current. Agreed?
Correct.
There is a corresponding variation IC. That's what I want to tell you. Corresponding variation IC. Okay? Now VO will have now two components. One is beta times IB into RC. This is the DC component. Another component will be beta times, Mr. Murthy, be cool, beta times IC into RC. see, this is constant. But this one becomes what? This one becomes variable. Because IC is variable. Got it? Hello, are you with me?
Yes, correct.
Now, aram se watch out. Now, if I increase RC, what will happen? If I increase RC, this will also increase. No doubt. This will also increase, no? If I increase RC, see here, IC will not, see, IC will have one value. IC will have one value. But if I increase RC, then beta IC RC will also increase, no?
IC will not change, no? Capital IC will not.
Capital IC will not change. Capital IC will not change, so correct. Yes, sorry. Hey, you are a good boy, man. No, yes, chalo kali very good, yeah. Such students are there, teachers बच जाएगा. क्योंकि teachers गलती किया ना, तो students पकड़ लेगा. नहीं तो बाद में मुझे पता चलेगा मैंने वो गलत निकाले, रात भर नींद नहीं आएगा मुझे. Taking good students like you will ensure that I sleep well. Thank you. Yes, this will not change. This will not change. But here, this will change. Do you agree?
Yes.
Because RC is increasing. If I still increase RC, then this will still increase. Got it?
How will you say to increase on this?
Increase means amplitude is increasing. Signal का amplitude increase होता है ना?
But
should decrease. Should decrease.
See here, sir, that the amplitude of that signal will become IB, no, sir.
No. This, see, beta times IB. Oh, I have written here beta times IB. Sorry, ma'am. Very sorry, ma'am. Very sorry. Galat. Sorry. Wait. Very sorry. Wait. VO, initially I wrote VO as what? Beta times IB. I wrote beta times IB into RC. Correct. This is what I wrote. Now, if I include VS, then this IC will be equal to IC plus IC. Because this IB will be IB plus IB. Correct now? Hello? Great. So this one, let me write it properly. So this will be beta times IB plus IS into RC. Correct now? Now it is okay?
Yes.
Sorry, कभी गलत लिख देता हूँ. So I will write here VO will be equal to beta times IB into RC plus beta times IS, beta times what I write here, IS into RC. Is it okay?
But IS is a
Signal current.
yes.
See, I am not here IB, I have written it as IS. Because of the signal current, because of this change in the voltage, there is IS.
See, what is the path of IS?
Huh?
Path of IS.
Path of IS, see, if there is a current source here, the path should be this only.
It should be that only.
That only.
Then here it should not
Here it should not.
matter.
This current source will depend upon this current, no? This current source will depend upon this. If this current changes, this current also will change. Understood? This current is controlled by this current. Correct? That is what is this relation. So beta IS RC. Got it? Hello?
Yes, sir.
So as you have rightly pointed out, see, these are two voltage components. One voltage component is this, corresponding to this. And this component is adding to this. Correct? So how will this component behave? This component will behave like this. Correct? Decreasing or increasing? Chalta hai. This is a signal which is varying.
Okay.
Got it?
They will add up, no, sir?
They will add up.
Yes.
They will add up. And that is why you will get, see. So this one will be like this. And this one will be like this. Got it? So if I add these two, I am going to get the signal like this. Got it?
Yes.
Addition. Huh.
Simple.
Okay, everybody is fine. Understood? Anybody has doubt? You ask. Huh. Now, if I increase RC, what will happen? This quantity will also increase. This quantity will also increase. Correct now?
Okay.
If I increase RC, this will also increase. This will also increase. Agreed?
Yes.
So IB won't change us.
IB will not change. And if I increase RC, then this value will also increase. No, if RC increases. And this signal will also increase. See, IS means what? IS means a varying signal. So, if RC increases what? The whole signal into RC, the whole signal will increase. The voltage level of the signal will vary. Correct now?
Yes, sir.
Get yourself completely convinced, not half convinced, because you are all going to write the exam. So you should understand it 100%. If you understand 99% also, no use. Okay, don't worry. We are all wonderful people. You, me, we are all doing justice. So God will help us. We should be sincere to ourselves. If I still increase RC, this will still increase. Agreed? Yes. Good. Now, see, this is what is the chamatkar. But if I increase RC, what is this signal? This is VS signal. Is this signal increasing or decreasing? No. Hello?
VS will not change.
VS will not change.
Yes, sir.
Now you see. So now you see. If I now take this signal as VO, and this signal is VS. So now if I write VO by VS. Now what is VO? VO is, what is VO here? Okay, now you aram se understand this. Now when I am telling VO, I am calling this as VO. This signal as VO. This signal, sorry, I will not now use this symbol here. Okay, wait, I started with this symbol, no? Okay, use this symbol. I will use a different symbol for this. This is a
VS dash.
VS dash. Okay.
Dash.
Wait, I'll tell you. So I told total VO is this. So this has got two components. One is VO DC and this is VO AC. Got it?
Yes.
Okay, let me make it. So now VO AC divided by VS. VO AC divided by VS. Okay? So I will now write VO AC divided by VS. So what is VO AS? Beta times. Okay. What is VO AS? IS into RC. Correct? Hello? And what is VS? What is VS?
Capital I plus small is into RC.
IS is the
What is IS? What is IS? See here, what is VS? VS is what? See, VS is what? VS is a small signal that I have introduced here, a small voltage that I have introduced here, a small voltage that I have introduced. That small voltage is giving rise to this current. So whatever current is rising because of this, that current will drop across this resistor. Correct? So that will drop across this and also this. See, because of here there is a current. That current will be dropped across this, plus it will be dropped across this. Correct? Huh? Okay. Right. Okay. Now, I can take one of these ratios, but I will take both of them. So still I will take this as IS instead of VS. I will write it as what? RB plus RB. Supposing I write like this. Is that okay? Now I can cancel this off. So I get here beta into RC by RB plus RB. Now let me explain this to all of you. Here beta is greater than okay, not very much greater, just greater than 1. Take beta is greater than 1. Now if you make RC also greater than RB plus RE. Hello, are you with me? So this whole quantity will be greater than 1. Got it?
Yes.
So therefore now VOAC will be some quantity here, some quantity here, that is this quantity, right? Into Vs.
So it should be greater than
which I am going to write it as AB. This quantity I will write it as AB. AB into Vs. Hello, are you with me?
Yes, sir.
Now AB is greater than 1, or sometimes you say AB can be 10, 20, 30, 100, 200, anything AB can be. So AB, assume that AB is 100, and Vs, that is a small signal, that is say you are singing hello, hello, hello. That can be say as less as 10 millivolts, or say even 1 volt. Say 10 millivolts, or say 0.1 volts. So what will be VAC? 0.1 into 100. VAC will be 10 volts. Hello.
yes, there is.
So what have you achieved here? Voltage amplification. A small voltage is now appearing as big voltage. So voltage is amplified. ठीक है, सबको मालूम है? अभी से हेलो हेलो किया तो लाउड स्पीकर में हेलो हेलो बजता है ना, वो ऐसे होता है, ट्रांजिस्टर एक्शन से होता है. Did you understand now how transistor works? Clear?
Yes.
See students, when you go to engineering college, right? This is how science will be used. See here what is used? Science is used and a device is developed. Diode. Now from a diode, science has established a transistor. Like that you will have multi-layer things, VLSI technology and all. Fantastic. Okay. You will love to live to learn. पैसे आता है, चैनिंग होता है, वो सब बाद में होता है. आपको you will find yourself entertained by learning only. मूवी जाके जो एंटरटेनमेंट मिलता है, फ्रेंड्स के साथ जो एंटरटेनमेंट मिलता है, वो ठीक है. इससे बढ़िया एंटरटेनमेंट आपको मिलेगा जब यू लर्न इंजीनियरिंग. And if you can learn and understand, nothing like that. So that is why I am telling you, your funda should be good. And this chapter is specifically introduced because you should now know that, because Newton's law है, वो है, and everywhere there is approximation. क्या होता है इससे? अभी देखो, ये सब सीखने के बाद you can seek that, and you can now see the application of science here. Can you ready the semiconductor center? So this is how engineering is done. I have only taught you a very very small amount of that. You are now capable of learning large amounts. So now did you understand how the voltage amplification takes place?
Yes.
The utility of current source, voltage source, वगैरह वगैरह and all? Huh? Good. Fine. Don't. Yes.
So except the amplitudes and other properties of like frequency and wavelength, will they be same for?
Okay. Good question. Abhi, you see, as long as you are operating the amplifier under linear condition, that is, the input-output characteristic must be linear. What did I say?
Input-output that should be linear.
वो बंदा नहीं बोल रहा.
Linear means?
Linear मतलब क्या है? बोल रहा. देखो, Okay, VO versus VS. Right? Now, supposing you do this experiment. You do this experiment VO versus VN. You give some amplitude, you see the output, you see the amplitude, and then you will get all these points. Assume, see this point is for this VS, VO, this VS, VC. And supposing if you connect all these points, it is a straight line. Then this is called linear characteristic.
Okay.
But supposing you connect these points and you get this point, this point, this point, this point like this, then it becomes what? Non-linear characteristic. Now, if the characteristic is linear, then if see, now characteristic is linear. Now see here, if for linear characteristic, if the signal say Vs varies within this band, Vs varies within this band. Okay, then what is the corresponding variation in VO? This is the corresponding variation in VO. Okay, hello? Supposing this width is A and this width is B. So here you will get a constant B by A. Now I will take this, the signal will vary from this point to this point. This is now C. And now the corresponding variation now is D. So now I will get the ratio D by C. So if D by A is equal to D by C, then if the shape of the signal is like this, the output shape will also be like this. Now, supposing it is non-linear, see here, A has changed by so much. Corresponding change in B is so much. Now C has changed by so much. Corresponding change in C. So in the case of this non-linear characteristic, D by A will not be equal to D by C. एक उदाहरण देखो, if you are using a linear amplifier, linear characteristic amplifier, so किशोर कुमार जब गाता है ना, वो आउटपुट लाउड स्पीकर में किशोर कुमार का ही आवाज निकलेगा, ठीक है ना? माइक पे किशोर कुमार होगा, लाउड स्पीकर से भी किशोर कुमार ही होगा। अगर एम्पलीफायर इज लीनियर, नहीं तो क्या होता है, इधर किशोर कुमार गाएगा और आउटपुट में कुछ और ही साउंड आएगा। Understood? That is what we call it as distortion. Distortion. If the shape of the output is not the same as the shape of the input, then there is distortion. If the input signal is say like this is the input signal, right? Now the output signal it can be amplified. So the output signal, if the output signal is also like this, then it is faithful amplification, and that is possible if the characteristics are linear. Otherwise, the output can have some other shape. Then it is not linear. So here, you learn this. These are all very, very interesting questions. Now you have to design the amplifier to work as a faithful amplifier. Amplifier by itself will not be faithful. It depends upon how you design it. The range, for a particular range, for a particular set of inputs and frequencies, only it will be linear. It will not be linear for all frequencies and all the amplitudes. There is limitation. These are all real devices. You are only learning the principles. Okay? Okay. Shall I proceed?
Yes, sir.
Okay. Good. Now, you see, I told alpha is equal to what? IE. See, now let us understand the sign convention. IE, I wrote it as equal to IB plus IC. I wrote this like this. Hello?
Yes, sir.
Now, if you take a transistor, okay? See, now this is taken as a node only, no? whatever current is entering has to leave.
Yes.
Understood? So now, that means now, if you take Kirchhoff's law, IE minus IB minus IC is equal to 0. Correct? So, therefore now, here you see when we are writing this relation, it is very clear that this current is entering, this current is leaving, and this current is also leaving. And another relation you have seen, what is the relation? If this current increases, this current will decrease. So there is phase inversion. There is phase inversion. If IB increases, IC will decrease. I mean, it is increasing positively, that will decrease negatively. So there is 180 degrees phase difference between these two signals. 180 degrees or pi will be the phase difference between it. I hope you appreciate that.
Yes. Yes.
So keep all those things in mind. So what I am trying to tell you here is, see, now I told voltage amplification, AB. AB is what? Small letter. Okay, or AB is what? Delta VO AC divided by delta VS. Agreed? Voltage amplification, man. Similarly, I will write something as current amplification. What is current amplification? Delta IC by delta IB. Agreed?
Yes, sir.
Delta IS.
Sorry, delta IS. So, but IS is in IB, so I can write it as IB. IS, I am taking it as IB.
IB plus IS.
IB is fixed. See, when I am writing here only signal variation, I am not talking about the constant variation. Only the signal variation I am seeing the total, not the totality. DC component will amplify DC component, AC component will amplify AC. And what is this? This is nothing but beta. So current amplification is nothing but beta. But what you have to now see is this IC, change in IC will be having phase difference. Change in IC will be having phase difference. That is, see, that is if the IS is varying like this is IS, then the corresponding IC, how will it vary? It will vary like this. Correct? Understood? It will vary like this. So there is 180 degrees phase difference between the two.
Minus here.
So therefore, we have to write it as minus. We will have to write it as minus. I suppose these are all very clear now. Very good, very good. You are all learning very nicely. So enjoy this. So there is voltage amplification and there is also current amplification. There is voltage amplification as well as there is current amplification. Now you see here only I write. So here voltage amplification will be what? I wrote there. If you remember, I said beta into RC by RB plus RE. Correct? So AB is beta times, or I will use minus sign to say that it is phase reversal, into RC divided by RB plus RE. I suppose you remember this. And this I can write it as what? Beta is A, or this is equal to what? AI into RC divided by RB plus RE. I can write it. Got it? So what you have to now understand is very important. See, the voltage amplification will depend upon which transistor you are using. So there are thousands of types of transistors, different specifications. So one of the specifications is beta. So the beta for this transistor is 10, beta for that transistor is 20, 30, like that. All that you have to do is you have to design for this. Then you will get the amplification. That is how amplifiers are made. This is very interesting, man. I can go on teaching you for hours. But you know, for your syllabus, what is restricted, I have to. But this much what I have taught is much, much higher than what is given. See, in your NCERT book, they have written all this I have taught. But in Sankshipt, it is for the teacher to explain it to the level students can understand. The teacher should not explain if the students are not understanding. Students are understanding, he has to explain. To that limit I have done, and I have explained to the maximum limit that is prescribed, and all of you have understood. I am very happy. So shall I proceed?
Yes.
Yes.
Okay.
Yes.
Good. Abhinav, late ಬಂದಿಯಲ್ಪ ಎಲ್ಲಿ ಹೋಗಿದ್ದಿ?
ಇಲ್ಲ ಸರ್ ಕ್ಲಾಸ್ ಟೈಮಿಂಗ್ ತಪ್ಪಿಕೊಂಡು
ನೀನಾ ಹೇಳಿದ್ಯಲ್ಲೋ 3:45 ಅಂತ. ನಾನು ನಿನ್ನೆ 3:30 ಅಂದ್ರೆ ಸರ್ ವಿಲ್ ಹ್ಯಾವ್ ಇಟ್ ಅಟ್ 3:45 ಅಂದಿ. ಮತ್ತೆ ನಾನು ಇನ್ನೂ ಮೆಸೇಜ್ ಕಳಿಸೀನಿ, ಇವತ್ತು ಕಳಿಸೀನಿ, ಎರಡೆರಡು ಸತಿ. ನೆವ ಸುಳ್ಳು, ಬೇರೆ ಏನೋ ಐತೆ, ಹೌದಿಲ್ಲ? ಇರಲಿ, ಆಗ್ತಾವ ಈ ವಯಸ್ಸಿನಾಗ ಹೇಳ್ಬೋದು. ಹಾಂ. So now you see, I'm just going to write the amplifier like this. So this is now, you know, so you are getting input here. So this is input side, and this becomes what? The output side. This is output. Clear? Hello?
Yes.
Hello?
Yes, sir.
So what will be the input characteristics? Input characteristic will be, see here, IV versus VB. This will be same as a diode characteristic. Because if you are forward biasing, forward biasing now.
Yes, sir.
So it is input characteristic. This is input characteristic. But now when you are doing this input characteristics, if you remember, we were okay. Now one more thing I have forgotten to tell. I will just tell it. Okay, I'll let me know. So when we did this amplifier, we had connected one source here to forward bias junction, correct? And we had connected one more source here to reverse bias junction, correct? See, why did we connect this? This is to forward bias the junction. Forward bias means what? I want to place the operating point here. That is why I have given this resistor, I have given this voltage source, and also the resistor. Got it? Then only I will fix the operating point.
That should be okay.
Okay. I have forward bias. So now what is it? Now I can say this is P and then this is 5 bias, this is this. Okay. Right. Hello. Understood now operating point? But what you have to understand here is the moment you connect this, that is the moment you reverse bias this junction. The moment you reverse bias this junction. So this will definitely have effect on this. Don't you feel so? Don't you feel? There should be some effect, no? There has to be some effect. Pardon?
Most of the current will pass through that.
Oh, it will pass. It will pass.
So it will have a
But you should also know that this is reverse biased. There is this is reverse biased. There is electric field now here.
yes, sir.
Depletion region electric field is created. So this electric field doesn't mean that only this will affect this junction. That electric field will affect this junction also.
Yes, that's
Hi Kiran.
that's it.
Yes.
See, now you have got two classrooms. So in one classroom, you are sitting and studying. So in the neighboring classroom, supposing a great man like Dr. Abdul Kalam comes, and he is addressing the students there. So the teacher will tell, see that side Abdul Kalam ji is addressing the students. Okay, so I am teaching here. So you will say, sir, today we want to attend Abdul Kalam sir's class. When I say, no, the class is full. So you have to listen to me. Okay, you are good students, you listen, but still your ears will be there. What is he telling? Don't you feel so? Hello?
Yes, sir.
So थोड़ा बहुत तो इसका इफेक्ट इसके ऊपर रहता है. जो रिवर्स बायस वोल्टेज देते हैं ना, that will have a bearing on this. That's what I want to tell you.
Yes.
So therefore, this characteristic depends upon. See, I am going to write a VCE one. What is VCE? Sorry, VC. Sorry, VCB. So here, wait a minute, I'll tell you. So here, this junction voltage, okay, or VCE or VCB. VCE means the voltage between this and this. So if you vary this, vary means not go on varying, then this characteristic will also change. Understood? VCE, if you vary here, that will change the input characteristic itself by a small amount, but that is significant on some conditions. So you should understand this, because this junction is very close to this junction. So this is how the input characteristic would look like of a transistor. Hello, is that clear?
Yes, sir.
Now let us come to the output characteristic. So output characteristic, before I teach you output characteristic, I have to teach you something else. What is it? Now you see, if you have a PNP transistor, and if you forward bias this and if you reverse bias this, okay, so the current will enter here. If you forward bias this, current will enter here. So there is a symbol that we have to use for the transistor. So the symbol for a transistor is this. So there are two transistors, one is PNP, other one is NP. Okay? Hello, are you with me?
Yes, sir.
Now, supposing I use this symbol, okay, then there will be some confusion. So what is that here? If you follow, see now this is base, this is collector, and this is emitter. For this also, this is collector, base, emitter. Now, if you forward see now the base emitter junction, base, see this is emitter base junction is forward biased. That means this and this are forward biased. Then the current, that is base emitter junction is forward biased. So what happens? How will the current flow? In this case, the current will enter the emitter and leave the base. Correct now? Hello? So you will put the arrow here. So in this case, you are forward biased. You are forward biased. This is base. So in this case, what happens? If you forward bias the junction,
The current will leave from
the current will
leave from
enter from base and leave from base. Correct? So you will put that here. Correct? So this is the symbol for NPN transistor and this is the symbol for PNP transistor. It is understood. This is understood. Okay, so you forward bias the junction and see how the current will flow. Conventional current will flow. That is the symbol for that. Okay?
Working of both the transistor is same, sir.
Same. But there is a small difference. I will tell you, that will be small. Only difference will be what you know. See here, the majority carriers from here will be holes, and this holes is what will go as the electrons. Here, it will be electrons and electrons. Correct? So, what can be the difference if holes are going and electrons are going? What can happen? Current is flowing through a conductor. What are the things you will consider? See, you know the drift current? Drift current depends upon what? the current, see, current in a conductor depends upon what? Concentration, the charge, and the drift velocity V. Vd is equal to what? Mu into E. You remember? So here you will have two mobilities. One mobility for hole and another mobility for electrons. And the mobility of holes is less than that of electrons because it is more inertial. I suppose I have told you this. So a NPN transistor, in a NPN transistor, the holes will move fast. So therefore, if you now use a NPN transistor and PNP transistor and build an amplifier, everything same, voltage, current, resistors, all same. But when it comes to frequency, so NPN transistor can handle higher frequencies. Much better. That is the fidelity. Fidelity means the shape of the output and the shape of the input. So you will get better quality if you use NPN transistor, okay, because of this speed, mobility factor. Now students, when I went for my M.Tech interview way back in 1988, this was the question asked to me. Understand? But frankly speaking, I didn't know the answer immediately. But there you see in stress interview, they gave me a small hint. What do you know about the motion of the charge? Just like how I gave you hint. I captured and said, sir, mobility. Mobility of hole is less, mobility of electron is more. Then what happens? This can go faster. So fast switching will take place. You will learn about it in higher classes. And therefore, it is better for you for high frequencies, NPN is better suited. I scored a point. Okay, so you see the examiners, especially in oral interview, you keep answering, they will go deeper and deeper and deeper. You give this answer, they will ask you the next question deeper, deeper, deeper. I was drilled for tube light for half an hour. Tube light, they kept a tube light in front of me, everything, and they told me to connect a tube light and make it on. That was my interview. See, tube light will not be taught in PUC also and in engineering college also. Okay, so but we have studied choke, this one, all that we would have studied in our theory classes. And I taught, and we have learned all that. But then, and every day I see the choke in my home, tube light, and choke, inductor design, everything. So if I have not observed what is a choke and what does it do, then I am a useless engineer. So these aspects they will bring out. That is why I am telling you, you have to be a good student. If you are a good student, you will learn from everything and anything around you. You have to be inquisitive. There is science in and around. Anyways, so this is how it is symbolized. Okay. So we have discussed this. So did I give you the symbols correctly for PNP and NPN? Okay. Hello. Right. Same symbols I gave you now. Only thing is I showed it like this. Okay. I hope you understood the symbols. Hello, everybody there?
Yes, sir.
Yes, sir.
See, Abhinav is a good boy. Now, transistor, emitter junction, forward bias, collector bias. Now I will tell you the next aspect of it. See, you can forward emitter base. See, this is emitter base, collector base. Okay. So you can, if you forward, see, you can either forward bias the emitter base or reverse bias the emitter base. It's up to you. So if you forward bias the emitter base and reverse bias the collector base, then we say the transistor is working in active region. There are three regions the transistor will work. Active region, cutoff, see there is, anyway, it is written. Then if you reverse bias the emitter base junction, forward bias the collector base junction, then it is inverse active. The name, I will explain this. Then if you reverse bias the emitter base, reverse bias the collector base, then it is called as cutoff region. I will explain all this thing. Forward bias emitter base, then it is called saturation region. Okay? Okay. Hello, are you with me?
Yes, sir. Yes, sir.
So I'll explain this in appropriate context. I'll explain. Now, if you want to use a transistor, see now there are many uses of a transistor. One of the uses is amplification. One of the uses is amplification. So it's already 5 o'clock.
For us, today for us.
No. I'm going out of station. I might have to stop the class. Wait. Okay. So, one of the uses of transistor is to work as an amplifier. So, if you want to use a transistor as an amplifier, then you have to ensure that during the when the transistor is working as an amplifier, you have to ensure emitter base is forward bias, collector base is reverse bias, then you can use it as an amplifier. Got it?
Yes.
There is one more use of the transistor. That is transistor. See here, transistor as amplifier. There is one more thing, transistor as a switch. Transistor as a switch. So if you want to use a transistor as a switch, then you will operate the transistor in these two regions. You will operate the transistor in these two regions. Okay? One is, you see, the transistor should be off. The transistor should be on. Then you will configure the transistor to operate like this. Okay? I will explain that. All this theory, all this is there for you. I will explain all these things. Okay, I will explain these things in detail. It will take a lot of time. But you have to excuse me, I am stopping the class now. I am going out of station today.